Now, let's talk a little bit about what maybe platform as a service has and container as a service has that function doesn't have. Non-restrictive task execution times. By this I mean there are many functions as a service platforms out there that will actually not allow you to run your function as a service indefinitely. Right? They have some sort of time limit, maybe 30 seconds, 5 minutes, 10 minutes, something like that. And eventually they'll kill your function because these are meant to be short-lived little utility functions, like as I said earlier, to get your job to do one job very, very well, get it done, and then exit. Right? Now, when you contrast that with platform as a service or container as a service, right, those things can't typically run forever because you can run any kind of job you want in there. So there's another difference between those two types of platforms. Again, non-restrictive resource usage. Many serverless or function platforms don't just limit the time that your functions can run, but the amount of memory they can use. Now, obviously, platform as a service and container as a service, you have similar restrictions there, right? You can set up your containers to only have a certain amount of memory. You're not going to have unlimited, but typically what we've seen so far for functions as a service and serverless is they have even smaller amounts that they'll allow you to actually provision, right? So they'll give you only a smaller amount of memory, smaller amount of CPU, that type of stuff, as you start writing the functions. Whereas platform as a service and container as a service, it's much bigger, right? And this all goes to why or how the infrastructure is actually managed under the covers. Typically, these functions as a service platforms are in shared environments, and therefore they can't allow you to necessarily eat up all of the resources within that virtual machine or piece of hardware because it's shared among other people. So they have to manage it in a much more tightly controlled fashion. Okay, so you have these three choices. There are pros and cons with each. None of them actually do everything really, really well. And my assertion is, why should you necessarily be forced to choose between these three? Because for any one application or any one environment in which you're hosting stuff in, you may want different aspects to all these, right? So why do you have to actually choose any of those three, or choose between one of those three? And that's where something different needs to come into play, and that's where Knative comes into it. But first, before we do that, let's talk a little bit about Kubernetes. Because Kubernetes is really becoming the most popular container management platform out there, right? There were other ones out there, and there still are, but really Kubernetes is basically eating the world. And at its core, Kubernetes is a platform to allow you to deploy and manage your containerized applications. And that's wonderful at a very high level, right? Understand what that is. However, once you start playing with it, you understand that Kubernetes, as powerful and as nice as it is, it's really, really complicated to use, right? I'll look at all these resources that I show here on the left-hand side, right? Containers, pods, replica sets. I'm not going to explain what all these are, but these are all of the resources that you, as a Kubernetes user, have to understand and manage, right? It's no longer this notion of give us your code, we'll host it for you. You have to understand all these various bits, how they work together, and how to manage them. Now, even aside from the resources themselves, you now have to learn a whole bunch of other tooling, right? You have to start learning YAML because Kubernetes seems to really, really like YAML, or JSON if you really want to, but most people use YAML. You have to understand the way resources are managed, tooling like Helm, the new command line, Istio, the networking mesh, all these other things that are just the tooling that go along with the resources inside Kubernetes, you have to manage yourself now and understand. If you want to do more complicated deployment mechanisms, like a blue-green deployment, you can do it with Kubernetes, but you have to do it all yourself. Other platforms, for example, Cloud Foundry, will help you out in some way there. Okay, so this entire promise of cloud native computing that we talked about earlier, with this whole abstraction as you're moving closer to the right-hand corner of that picture or of that graph, where you no longer have to worry about the infrastructure, it's almost like it's falling apart at this point, right? Because Kubernetes almost backtracks, right? You now have to understand all this infrastructure, and you almost have to become an IT expert all over again, which is sort of backwards to what we're trying to go towards here, right? This whole notion of decreasing concern and control over the infrastructure is no longer true. And that to me feels like a step backwards. So let's go to what people really, really want, right? They just want to deploy their code. They don't want to have to worry about this infrastructure. And that's where Knative comes into play, okay? So at a very most basic level, Knative is just an opinionated, simplified view of application container management. What that really means is it's a simplified view of Kubernetes, okay? So it allows developers to go back to focusing on writing code by allowing you to leverage the abstractions that we've already know and love from things like serverless, platform as a service, and those kind of places, but using it in a Kubernetes world. Okay, so what this really is it takes Kubernetes, extends it, so you still have Kubernetes under the covers, right? You still have all those wonderful features available to you, but it presents it to you in a simplified fashion. However, if the need arises where you have to go around that opinionated view and get access to more complicated features, because Kubernetes is still there, you can still get to those. And that's the benefit of it, right? With Knative, you get the simplified user experience with the advanced functionality behind the scenes. But if you really want to, you can get to the advanced features yourself directly if the opinionated view gets in your way of doing what you need to do. Now, because Kubernetes is still there under the covers, what that means is you can still run your existing Kubernetes workloads alongside your Knative workloads, and they can interact together just nice, perfectly well, because everything is still running Kubernetes resources under the covers, right? So you still get a single world just with a simplified view if you choose to. Okay. Now, Kubernetes, when it first came out, was advertised as a platform on which to build other platforms. But as we all know, or those of you who use Kubernetes know, Kubernetes became the platform that people talk to directly. Now, Knative is being advertised as a platform on which to build a serverless platform or a platform as a service platform, right? You're not necessarily meant to talk to Kubernetes or Knative directly, at least that's what they're advertising. Whether that plays out for real in the future, who knows? But for right now, a lot of people do talk to Knative directly, so it is still in this mode of it is the platform people will talk to when they start wanting to deploy these simplified applications. Okay, so let's talk a little bit about what Knative actually is under the covers. Under the covers, Knative has two main components. First is serving, and as the name implies, serving is the environment or the component that hosts your application. Very, very simple, meaning it uses Kubernetes pods under the covers, just presents it to you in a very simplified fashion. The second component is eventing. Now, eventing basically allows you to manage those events that come into the environment, because remember we talked about serverless and functions, right? They're supposed to be event-based, right? So as the events come into your environment, you may need to manage those events beyond just deliver it to my service, right? It may be, oh, I need to possibly persist it into some sort of queuing system because my service may be down for temporarily doing something, or maybe I need to have it fan out and get sent to many different services, right? A whole bunch of orchestration type things. Eventing gives you the basic building blocks to actually build up those workflows. We'll talk a little bit more about that later. So let's dive a little bit deeper into Knative serving, since that's the heart of Knative. Now, Knative introduced the notion of a service or a Knative service. Don't confuse that with the notion of a service in Kubernetes, which is more like an endpoint, right? Knative service is basically your application. Now, within your application, what you're going to have is versions of your code, right? Meaning versions of your application. Each version has associated with it a configuration. So as you make changes to the configuration, whether it's to change the Docker image that's being used or change some configuration parameter, that's going to be associated with that particular version of your application. Now, once you deploy that version or revision, Knative is going to set up an endpoint, meaning an external URL that a user can now hit. So it's going to set up the networking for you automatically, right? Simplified user experience. All you did is give it the application. It starts doing all the magic under the covers for you. Now next, as the application gets hit from the end user or through whatever system is sending events to it, it will scale up versions of the application. So it will scale up, to create, in this particular case, 3 different versions of revision 1 based upon the amount of load coming in. And I get to control how quickly or slowly things scale up and down. And again, as I mentioned earlier, because this is kind of serverless and function-based, or they're stealing a lot of ideas from there, it will scale down to 0 if no one ever actually calls that version of your application. Now next, when you choose to roll out another version of your application, and by the version I mean you've changed the container image you're running, or you've modified the configuration file, Knative will treat that as completely completely new version. So it'll create, in this case, version 2, and then it will slowly route all traffic over to version 2. And eventually version 1 will just go away, right? So it does this automatic rolling upgrade for you. Again, you don't have to do anything manually yourself. It does it all for you. However, if for some reason you do want to actually have 2 different versions of your application out there and you want to do some sort of traffic splitting, so for example, as I'm showing here, you want to have 90% of the traffic go to version 1 and 10% go to version 2 for a while, so you sort of test it out to see whether it actually works. You can do that. You can ask Knative to do that for you in a very simplified fashion, and I'll show you how to do that in a demo. Now this picture here shows traffic splitting based upon percentage based, and that's all you can do today in Knative. There is work going forward so you could do traffic splitting based on other things, but for right now it's basically just percentage based. Okay, finally what you can also do is set up a dedicated URL for a particular version of your service. Now, look at the top part of my picture, right? I have a single endpoint. Where's my cursor? Nope, I don't have my mouse. Okay, anyway, the top little green endpoint box, that represents a single endpoint that's sort of in front of version 1 and version 2. You could think of that as the main entry point to your service, and Knative will manage that for you. However, let's say I have a situation where I want to create a version 3, which is really, really new code, completely untested. I don't want anybody to hit it except my testers. What I can do is I could tell Knative to create another version by giving it a new Docker image as an example. And I'm going to configure it in such a way that I ask for a dedicated endpoint just for that one, but to then also exclude it from that main entry point, meaning exclude it from that routing, percentage based or not, from the above picture. Okay? That way my testers will know about that dedicated endpoint and they'll hit it and they'll be able to test it for me, but the rest of my user base will still be using version 1 and version 2. Okay? And that's basically the main points of what you can do with the Knative serving model. And the key thing here is that Knative will manage all of the resources under the covers to do this for you. Now, because some of you who may understand Kubernetes you guys know that in order to make this happen, there are a lot of resources that have to be created, right? You have endpoints, load balancers, Kubernetes services, pods, replica sets, all this other stuff that has to be created. As a Knative user, you're not exposed to any of that. I'm only exposed to the Knative service. That's it. There are going to be configuration options on there so I can control things like the percentage-based routing, asking for a dedicated endpoint, but that's all within the scope of this Knative service. So you have a very simplified user model being exposed to you. All right, so a couple of things to understand about Knative serving. First, because Knative serving assumes everything is event-based, you must have an HTTP server running within your container, right? So this notion of start a container that just does some work and then it's done doesn't really exist, right? Everything has to be initiated through an HTTP connection coming into your service. Okay, that's why you have to have an HTTP server running there. Next, everything is multi-threaded by default. Notice when I talked about that container concurrency, right? I set it between 0, meaning infinity, and 1. It assumes, because you have an HTTP server running there, that the HTTP server will spin up threads, and each thread will process, one request, and that's what I mean by a multi-threaded model. However, as I showed you, it is configurable. So if for some reason each instance of your application, meaning each pod, can only handle one request at a time for some reason, you can set the container concurrency down to 1, just like I showed you in the very beginning of the demo, right? That's perfectly allowable. So that makes it act more like a traditional single-threaded application. That's perfectly fine.